Today we're going to discuss operations with radical expressions. A term you need to know, like radicals. Like radicals have the same radicand. For example, here we have a 2 radical 7 and a 5 radical 7. Okay, those are considered like radicals. In example 1, we're going to look at combining like radicals. Simplify 2 square root of 7 plus 5 square root of 7. Since both contain square root of 7, we are going to add their coefficients, which are the 2 and the 5. And you can see here, we combine the 2 plus 5. The radical remains the same, so our answer is 7 radical 7. In example 2, we're going to simplify to combine like radicals. Our problem is 7 radical 2 minus 3 radical 8. Okay, as we examine, we have 2 different radicals, so we can't add them just yet or subtract them just yet. What we can do is examine this 8. Radical 8 can be written as radical 4 times radical 2. Since 4 is a perfect square, this can be rewritten as 2 square root of 2. And what we did there is 4 right here was a perfect square. The square root of 4 is 2. So we come out of the radical here. We still had 2 underneath the radical. Don't forget the original coefficient of 3, thus becoming 3 times 2. We had to go back and look at our original coefficient of 3, which is there, and here we brought it down, and our new coefficient of 2, that's where that comes from. Multiply those together and we get 6 radical 2. Now we have 2 like radicals. 7 radical 2 minus 6 radical 2. Both contain radical 2 so that we can combine the coefficients. Seven minus 6 radical 2 is equal to 1 radical 2, or we can simply write the answer as radical 2, because we always know there's an understood 1 there. Okay, now let's go down to example 3. In example 3, we're going to use the distributive property. It says simplify radical 5 times parentheses radical 8 plus 9. First thing we're going to do is we're going to distribute that radical 5 here. Distribute it to everything inside our parentheses. There and there. Which gives us radical 5 times 8 plus radical 5 times 9. And since both of these are under the radical, we can multiply them. Radical 5 times radical 8 is radical 40. Plus, now I'll rewrite this as the radical last here. Okay, the next thing I want to do is look at the factors of 40 of which one will have a perfect square. Okay, those factors are going to be 4 times 10. Okay, 4 is a perfect square. Square root of 4 is 2. So we bring out the 2. We have 2 radical 10 plus 9 radical 5. Is there anything else that we can do? No, we don't have like radicals. There's no more perfect squares than 10. So this would be our final answer. Okay. Example 4, we're going to look at simplifying using FOIL. I have radical 6 minus 3 radical 21 times radical 6 plus radical 21. Okay, remember using the FOIL, we do first times first, square root of 6 times square root of 6 equals square root of 36. Outside, radical 6 times radical 21 equals radical 126. Inside, negative 3 radical 21 times radical 6 equals a negative 3 radical 126. And our last times last, negative 3 radical 21 times radical 21 gives us negative 3 radical 441. Okay, now I can simplify my radicals. Square root of 36 equals 6. I combined my like terms here. I had negative 3 radical 126 plus 1 radical 126 left me with a negative 2 radical 126. Now in doing that, I went ahead and broke that 126 down into its factors, one of which is a perfect square. Our 9 there. 9 times 14 is 126. Okay, and in my last term, I've got negative 3 radical 441. The square root of 441 is 21, so I bring it out here. Square root of 441 is 21. Now I'm going to multiply negative 3 times 21. Okay, here in our next step, you can see the square root of 9 was 3, so I brought it outside the radical here. So I've got negative 6 minus 2 times 3, which is negative 6, square root of 14. Okay, but I've got like terms here, 6 minus 63. So that becomes negative 57, which happens to be our final answer. Okay, example 5. Example 5, we're rationalizing the denominator using conjugates. Okay, conjugates is probably a new term or one you haven't heard in a very long time. So I'll remind you that conjugates are the sum and difference of the same two terms. An example of this would be the square root of 5 plus the square root of 2, and the square root of 5 minus the square root of 2. The product of the two conjugates results in a difference of two squares. To prove it, we have square root of 5 plus square root of 2 times the square root of 5 minus the square root of 2. If I do the full method, I'll see that my first times my first gives me square root of 25. My outside, square root of 5 times negative square root of 2 gives me negative square root of 10. My inside, square root of 2 times square root of 5 gives me plus square root of 10. And my last times last gives me negative square root of 4. Okay, if you'll notice, I have a perfect square here. I have a perfect square there. And these two, I have a minus negative 10 minus the square root of 10 plus square root of 10. That's simply going to cancel itself out. As I bring it down, square root of 25 is 5, minus the square root of 4, which is 2, and 5 minus 2 equals 3. Remember, we never want to leave a radical in the denominator. This is why we need conjugates. In our problem here, simplify 8 divided by square root of 7 minus the square root of 3. Okay, the first thing we're going to do is multiply the top and bottom by our conjugates. The conjugate of radical 7 minus radical 3 is radical 7 plus radical 3. And remember that you can always multiply anything by 1. It doesn't change the value of it. All this right here equals 1, does it not? I've got the same thing over the top of each other. So that tells us, by using that rule, that we can do this. Okay, so what we're going to do, we know that from our proof up here at the top, where I proved to you what conjugates do, we can now apply it to the bottom. Radical 7 minus radical 3 times radical 7 plus radical 3 gives us 7 minus 3. And then at the top, I'm just going to multiply our 8 times radical 7 plus radical 3 gives me 8 times radical 7 plus radical 3. So what I end up with is 8 parentheses radical 7 plus radical 3 divided by 7 minus 3 is 4. I know by my rules of division I can cancel out. That 4 becomes a 1. That 8 becomes a 2. So that cancels out, and it comes down to 2 parentheses radical 7 plus radical 3. Now I'm using the distributive property here and here. Gives me 2 radical 7 plus 2 radical 3. Enjoy.